Hello and welcome. The purpose of this lecture is to focus a little more on MRI to help prepare you for the activities in this module. You can look at the brain in many different ways. We'll mostly be looking at 2D representations of each of the three views we've discussed as we move throughout the course. You can also use 3D images, which can even separate anatomical points of interest. The image on the bottom shows loosely what is being analyzed in fMRI. You have clusters of nerves, and as blood moves in, the signal they emit changes. When we look at fMRI results, they are mapped onto structural MRI scans, so we can see where these blood flow changes are taking place. Everybody's brain is shaped differently. This seems obvious, but presents a problem for experimental research. fMRI records data in a fixed coordinate plane. That is, no matter where the participant's head is located, the 3D box data are collected in stays in a fixed location. The coordinates for one person's midbrain might be different from another. How can we compare coordinates of activation across participants then? On the left, you can see raw images. Generally, a standardized atlas of brain locations, often the Montreal Neurological Institute or MNI template, is used to warp the raw images so that locations can be compared across brains. This is an important part of fMRI analysis and will be covered more later. Basically though, without these standard systems, making comparisons across people would be tough. Generally, the anterior commissure is the origin for these transformations. Knowing where this commissure is, as well as other structures, can help you better interpret your fMRI results once overlaid on a normalized structural scan. Learning some structures in the brain can help you with your interpretation of fMRI results. This is helpful because even if you're not immediately aware of what part of the brain the results are located in, you can at least identify a nearby landmark and orient yourself. In Module 1, you did an exercise identifying some of these structures, but let's go over some of these landmarks. These include the central sulcus, which divides the frontal and parietal lobe, the lateral sulcus, separating the frontal, parietal, and temporal lobe, and the preoccipital notch. There are many more, and to be honest, getting used to the anatomy of the brain can take some time. With regards to the interior of the brain, there are lots of bilateral landmarks which are helpful to know. However, while they are easily located in this image, finding them individually in an actual brain scan is much more difficult. Once you're comfortable with these though, they are useful midbrain structures to know and be able to identify. Some other internal structures include the corpus callosum and the lateral ventricles. The corpus callosum is easily visible on a sagittal view, and the lateral ventricles are visible from most views. So, now we're going to see how well we can identify structures in the brain during the MRI connectivity and the scavenger hunt. Your knowledge of anatomical locations will be tested, and you'll be asked to find locations on images of real brains, on MRI images, as well as on other sources. It is expected that you will try and do these individually.